week 1, day 2 of our data analysis camp. I welcome those people joining us from the Accra and Kumasi. I also welcome those joining from the Nairobi, Kenya. I welcome those joining us from the Australia and those joining us from the United States. So you are welcome to tonight's class. And then our own here, those joining from Nigeria. So you are welcome to tonight's class. So let's set the ball rolling. So tonight we are going to be looking at the hands-on data analysis with Excel. Remember that we've set the foundation yesterday about the Excel, how we can make our Excel ready for data analysis. And I mentioned it that the first thing as a data scientist or as a data analyst is that once you get your data, you have to describe your data. Describe your data. That is when the concept of descriptive statistics will come in. You describe your data. Do I have missing value in my data set? Do I have the outlier on my data set? And then what type of variables am I working with? Is it categorical variable? So if it is categorical variable, we explained yesterday that we are going to represent that with the with the bar chart or pie chart, which we demonstrated the use of pie chart yesterday. And also, if it is continuous variable, we use histogram, where we demonstrated the histogram for age yesterday. And also, we also check the relationship or the association between two continuous variables using the scatter plot, which will later find the regression line and then the equation on the line. So tonight we are going to be checking what we call the testing of hypothesis. What is statistical test? What is testing of hypothesis? How do you find a relationship, a model for relationship? How do you develop a predictive model? Those are the things that we're going to be checking tonight. And remember, everything is still narrowed down to your variable classification concept, because if you classify your variable correctly, you are going to use a correct test. So if you misclassify your variable, automatically you are going to use a wrong test, which is going to give you the wrong result. And then if the policymaker makes use of that result, it will lead to a great error, and it can cause damage to the society. Please take note of that. It's very, very important. Now, objective for tonight, we're going to be performing hypothesis testing, then the data-driven decision making. We're going to be using the F. We're going to be checking the Z test, the F test, the T test, the correlation and regression. And also, I would have loved us to check chi-square in tonight's class. But one of the limitations of Excel is that Excel don't have the function for chi-square. You can't find the function of chi-square in Excel. So when we get to our SPSS, which we are going to start next week, I'm going to be showing you how to use chi-square concept to find the association between two categorical variables. Remember, categorical variable is still the same thing as the qualitative variable, and then the numeric variable is the same thing as quantitative variable. So please take note of that. It's very, very important. Now, I want us to clear the air, because over the time now, if I ask people, what test do you want to use to actualize your objective? I will just hear them saying, I want to test the hypothesis. There is difference between statistical test and test of hypothesis, but there is just like a thin line in between them, but they are not the same thing. So I'm going to be clear that tonight. When we're talking about the statistical test is a general procedure or method used to analyze data. If I ask you, what statistical test do you want to use to analyze your data? You can tell me that I want to use a t-test. A t-test is a test. It's a statistical test, not the hypothesis. So if I ask you, what is your test of hypothesis? Don't tell me that you will be using t-test. T-test is not test of hypothesis. It's a statistical test. So we use it to when you are doing the analysis of your data to decide whether the evidence support or claim is valid or not. Now let me not link the two together. For example, example of a test, we have what we call the t-test. We have what we call the f-test. The experiment that we normally carry out to get the F-test is what we call the analysis of variance. Analysis of variance, which is ANOVA. The short form of ANOVA that you are seeing here, it means analysis of variance. So analysis of variance is not a test. Don't go and be saying that in a conference, or when you are presenting your research, or when you are presenting your dissertation or thesis. Don't go and be saying that I use analysis and ANOVA test. There is nothing like ANOVA test. ANOVA is just an experiment. At the end of the day, the test that we want to achieve is the F-test. Now, and then we normally use F-test when you have more than 2 groups. When you are comparing, or you want to check whether there is association or relationship in more than 2 groups. For example, now, if I want to check if a particular drug works effectively in some part of Nigeria, let's say, for instance, I pick from the southern part of Nigeria, I pick from the northern part of Nigeria, I pick from the eastern part of Nigeria, and I want to check whether the same potency of drug, the same potency that is that the drug we work with in southwest will still be the same thing that is going to work with in the northern west of Nigeria. It will still be the same thing that is going to work with the south. So I have more than 2 groups. So we normally use the F-test by carrying out the analysis of variance. Now, in chi-square test, if I want to check whether a student is going to pass, remember, if a student, for those in education, if a student pass or fail, if I want to check, is there any association between student passing and then their gender? Remember, gender too is a categorical data because it is either male or female. And then it's either you pass or fail. It's also a categorical. So if I want to check, is there any association between you being a male passing this exam, or is there any association between you being a female passing this exam? We normally use what we call a chi-square test. A chi-square test is a test that we normally use when you have 2 categorical variables and you want to check for the association or you want to check for the relationship between 2 of them. We normally use what we call the chi-square test. Please take note of that. It's very, very important. And then we normally use t-test when you have categorical variable and continuous variable. What did I mean by that? Let's say, for instance, now you now want to consider scores. The score of this student based on their gender. Remember, score is a number, it's a numeric variable, where gender is a categorical variable. We normally use t-test in carry out that. That is the simple explanation when we're talking about the statistical test. Now, let's check what is meant by the test of hypothesis. Let me explain in layman terms before I check what I have here. Let's say, for instance, now, you have a particular, you know of a particular insurance company. For those people into insurance, you know that this particular insurance company, the money that they make every year is 100,000. Is 100,000. That is, they sell hundreds of thousands of shares, or the people come to do life insurance. Now, this is if they come out and they started telling us that, okay, we make 100,000 in a month in our insurance. It is their claim. That is their own claim. Anybody can have claim. That is their own claim. Now, their claim is what we call the hypothesis. Hypothesis is your belief that is not yet verified. It is your own belief. If you believe that if I use this paracetamol, it's going to reduce my headache in 1 hour, it's your belief that is not yet verified. Now, by the time you now subjected it to the test, that is, let's say, for instance, you now sample like 10 people that are suffering from headache, and you now give them that drug. The drug that someone has claimed that if you use it for 1 hour, is going to lower down your headache. If you now give that drug for that 10 people, if that drug still work for the same hour that that person have claimed, that means that the hypothesis that the person owed is valid. Otherwise, it is not. Let me also come again. Let's say, for instance, now, a sound lawyer that you've heard about him, that he has won several cases. And he also claimed that if I go to the court with the knowledge of my law of argument or for the past, or with the knowledge of the case, my prior knowledge of the cases that I have won, if I handle this case, I'm going to win. I'm going to win. Let's say he's handling a criminal cases. That is his own hypothesis. Let us now say you as a researcher, you now want to check before you give that particular case to that particular lawyer. You now make your findings and you get those cases that he has won, the data and some things that he has used to win that particular cases. So that means that by the time you now subject that to a particular test to check whether the claim of that lawyer is going to be valid or not, before you give that lawyer that a particular case, then you can ask what you can say, okay, we are retaining this hypothesis or we are rejecting his claim. Lastly, let me bring an example for those that is in engineering. Let's say they've developed a particular company, develop a particular engine that can last for 5 years, and that is their claim. Their claim is that if you buy this particular engine, maybe for your motor car or for your tricycle or your motorcycle, that if you buy this particular engine, it's going to last you for 5 years. Now, let us now take, for instance, now you now want to test their claim. Then you randomly take the sample of, let's say, 50 people that have bought that engine, and you now study them over time. You study them over 5 years, and you now subjected their data to what? To a test, a particular test, to check whether the claim of the part of that company that if you buy this particular engine is going to serve you for 5 years is true or not. That is what we call the hypothesis. In a nutshell, hypothesis is the claim that is not yet verified. It is very, very important that you know the difference between the hypothesis, test of hypothesis, and the statistical test. Now, note, a test of hypothesis is the thinking process for checking a claim. When you are thinking that is the statement that this particular person said, is it true or not? That is why if someone comes out today that I have a cure for HIV, it is just his claim, until a scientist or researcher they take a random sample, let's say 1,000 people suffering from the HIV, and they administer that drug that the person has claimed that is going to cure HIV before they can answer, oh, your claim can be old, your hypothesis can be accepted. If not, such hypothesis is going to be rejected. So please take note of that. In general, a test of hypothesis is about asking question. You ask your question. That is why a research hypothesis is being battered from the hypothesis testing is being battered from research question. Research question is that thing that is bothering you that you want to research on. That one will not give back to what we call the hypothesis testing. And the statistical test is a tools we use to find the answer. The answer to the test of hypothesis, we normally use statistical test or statistical test tools to find the answer. So by now, you should know the difference between the statistical test and test of hypothesis. Test of hypothesis. Now, if you look at this, my diagram at my left-hand side, by the time you hold the lens that you are holding to fill all those lines is what we call the statistical test. That lens. So by the time you take that lens closely to the claim, the claim that that person has claimed, then you will see it clearly. Is it true or not? So statistical test is a lens that we normally use to check the hypothesis testing. Now, a hypothesis is an idea or guess that you want to test with data. So we normally use data to verify your claim or your hypothesis, which is very, very crucial for a data scientist or a data, if you're a data analyst or a data scientist. Now, look at this example. This is just like a claim from, let's say, from the nutritionist. Eating fruits every day makes people healthier. That is their claim. Now, let us now say, for instance, that you as a researcher, you now took a sample of 20 people that every day of their life, they normally eat fruit. They normally eat fruit every day. You now study them over time. Then you can now see whether the claim made by this nutritionist is correct or not. So, now let's check a few examples from different fields. In health, you can have the hypothesis people who exercise regularly have low blood pressure than those who do not. That is the claim. That is their belief. So you as a researcher now, you will not subject that to a test by using this appropriate statistical test. So statistical test, you can test by comparing those with blood pressure. You can compare the average blood pressure of the two groups, the group that they normally exercise and the group that they don't normally exercise. So in that case, you can use what we call the t-test to check. T-test, statistical test is t-test to check whether the claim is correct or not. Now, in agriculture, you can have the type of fertilizer, let's say fertilizer A, B, C, affect the crop yield. Maybe over the time, the farmer has observed that. Now, before you now accept that claim, you can now what? Check that data that the farmer has recorded in terms of yield over time. While you use fertilizer A, he has the record for the yield. Using the fertilizer B, he has the record from yield, and using fertilizer C, he also has a record from yield. Then you can now subject that to a test. And then I told us that anytime we're having more than two groups, we normally use what we call the F-test. And then the experiment that we normally perform is what we call the analysis of variance. Remember, analysis of variance is not a test. It is just an experiment to achieve the F-test. In education, we want to check the hypothesis for the educationist. Students who attend extra classes score higher in exam than those who don't. If you want to check that, you can randomly select, let's say 100 students, and you just put them in two groups. Those groups that will be attending the extra classes, like the extramural classes, and those that don't attend. So when you now study them over time, then you cannot test whether that claim is correct. So that if you are making recommendation for a school or for the Ministry of Education, you have your claim. You have your claim to hold on to that. Based on my research, I discovered that students who spend extra hour, they have higher score. So if the Minister of if the Minister of Education want to implement anything, they will focus more on increasing the hours of the hours that the people that the student will be using to study based on your own claim, based on your results. In finance, for those people in finance and those people in marketing, also we still have some of the people here that they are currently running their PhD in marketing and finance. So you may want to know, running online ads increase monthly sales compared to those that don't run the ad. Let's say, for instance, now you have a business and someone is now telling you that running ads will give you more sales. That is his own claim or our own claim, because he has what? He or she has tested it. Now for you now, you cannot take a sample of, let's say, 10 companies or 20 businesses that they run ads and check their income, their sales before they run ad and after they run the ad. Then you cannot compare between the sales. Okay, before I run the ad, I make 400,000. Then after running the ad, they make something like 600,000. You cannot do the comparison before you now conclude that, oh, there is a significant in running ad. That is, running ad has brought significant difference in your income. So before you cannot accept that, before you cannot venture into you running ad for your business, then you have an evidence to hold on to that. Oh, if I run ad, my business is going to be boom. It's going to what? It's going to skyrocket. Now, you may want to what? Also predict how the ad predict the sales. That is, the amount that you spend on ad. How can you use it to predict the sales? If I spend 50,000 on ad, what is my sales? What if I increase it to 100,000? What is my sales? What if I increase it to 50,000? What is my sales? So by the time you can develop an equation like that, like a simple regression model. That is, by the time you put 50,000 in, your output will be, you are going to have this also amount. If you put in 100,000 in, you are going to have this also amount. So by that time, you have a model to rely on based on the sample of the data that you've trained your model with it. Now, let's look at another example for those people in African study. We have people here that are in African study. Now, let's look at this hypothesis. Students who learn African history in their local language perform better than those who learn it English or French. Let's say, for instance, now, maybe those our friend from Ghana, maybe there is a particular language that they speak in Accra or Kumasi. Let us now say, for instance, you now want to teach students or the culture that they normally do in Accra or the culture that they perform in Kumasi. If you use the language that they speak in Kumasi for a particular set of people, and then you use another language that what's it called, their professional language. Let's say, for instance, that their professional language, let's say it is English or French, and you use it to also train another set of people. You now want to check their performance in terms of their understanding about the history of Kumasi or the history of Accra. So by the time you now subject that to a test, you cannot claim that teaching students with the dialect language help them perform better compared to teaching them with the lingua franca. So in the case of that, we can use what? We can use t-test. Now, lastly, for those people into fashion designer, you may want to check if customer prefer color A over color B in a new clothes. Customer A, remember, we have just two customers. Is that customer A or customer B? Then color is a categorical variable. Please take note. Color is a categorical variable, is a qualitative variable, it's not a number. So by the time you now want to compare the two categorical variable, we normally use chi-square. Chi-square will now tell you that there is an association between the color that this customer are choosing based on the prefer. That is, customer A prefer color red, customer B prefer color blue. So by the time you want to go to market to buy goods, you will know the right color to buy based on your data, so that you will not see as if that, okay, I've bought this particular color for like 6 months. Nobody is asking for it. It's because you don't keep your data. If you keep the data and the record of how you are selling those colors, by the time you subject that to a test, you have an insight of a particular color that they prefer, and then the particular customer who love this particular color. So by the time you want to make your decision in getting new clothes, you will know the particular color to get that is going to sell on time instead of timing your capital down. So with the knowledge of these statistics, you will be able to make the right decision and the right choice. Now, choice of test based on the variable type. Now we still go back to the variable. That is why I mentioned in our first class that the knowledge of variable classification is very, very crucial. Very, very crucial. So when you have a grip knowledge about the variable classification, you will find it easier in carry out your data analysis. Because once you classify your variable correctly, then you will know the right test to choose. Okay. Now, please take note of this. When you have one categorical variable, whether 2 groups or 3 groups, but it's still a categorical. So when you have 2 groups, one categorical, let's say for instance gender is a categorical variable, and then under gender we have 2 groups, male or female. For we here is still male or female. So, and then you now have one numeric variable, then you can use what we call independent sample t-test, or you use peer t-test if you want to compare before and after. Now, let's look at the second one. When you have one categorical variable with more than 2 groups, we have that variable, and then we now have more than 2 groups. Let's say, for instance, now, when you want to check the pain severity, so we have more than 2 groups, and then you still have one numerical variable. You are going to use what we call the F-test, which is analysis of variance experiment. Now, if you now have 2 numeric variables and you want to check, is there any relationship between 2 of them? What type of relationship that occur between 2 of them? There are 2 continuous variables, or the 2 qualitative variables. Sorry, the 2 quantitative rather, the 2 quantitative variables. We normally use correlation, whether you use the Pearson correlation or you use the Spearman correlation, to check if there is association between 2 of them. And then you can also know the degree of association that occur between 2 quantitative variables. Remember, If it is two qualitative variable, which is categorical variable, you are going to use chi-square. But if it is two quantitative variable, which is numerical variable, you are going to use correlation, which is either Spearman or Pearson. And then if you want to now predict what is the effect, what contributes to my outcome, you want to check the relationship or the contribution or the prediction of my outcome, then you can now use what we call the regression analysis. Regression analysis. We are going to be checking all this tonight. So now let us now say, for instance, now you have multiple predictors for one outcome. Let's say, for instance, you want to check the yield of a crop. The yield of a crop is your outcome. And then you now want to consider several predictors. Remember, I told us that another name for predictor is independent variable. And then another name for independent variable is still explanatory variable. So by the time you now want to check the type of crop, the soil, the type of water, and then the sunlight, you have more than one independent variable to predict the yield of a crop. We use what we call the multiple linear regression. Let us now say, for instance, now you want to predict the blood pressure based on the exercise, based on the type of food that you eat, based on the amount of water that you take in. We have 3 independent variables like that to predict the blood pressure. You are going to use multiple linear regression. Let's say, for instance, now you want to predict your sales based on the type of customer that you have, the income of your customer, how often your customer patronizes you, and then the amount of money that you spend on ad. Then you have more than one variable like that. You can use what we call the multiple linear regression. Let's say, for instance, you want to predict the lifespan of a particular engine based on the company that produces it, based on the material that they use, and then based on the past experience of those that have used that particular engine. Then we are going to use multiple linear regression. So this particular training that we are currently running, it's cut across all fields. Just take the knowledge and go back to your field and do the implementation. And let me say this expressly, that as a data scientist or as a data analyst, you should be able to handle any data from any field, because it is still the same principle. Once you check the topic or the title of that work, you link it with the objective. You will see whether the objective really captured the topic. Once the objective captured the topic, you link it to the method. What statistical method am I going to use to actualize each objective? From there, you link into the result. At the end of the day, the result that I have, is it explaining the objective? As it achieved my objective? Then you are going to conclude. This is what happened in all fields. That is why if you see a professor or a learned person attending a conference which is not in his or her own field, you will still see them contributing. They are contributing based on the link between the topic to the objective, to the method, to the result, and to the conclusion. So on this note, thank you so much for listening. Before we move to our practical class, let me welcome 2, 3, 4, 5 questions. So if you have a question for me, you can just signify, and then I'm going to open the floor. Thank you. Question, please. Okay. Osman Adamu, go ahead with your question.
Yeah, thank you for giving me the chance to ask a question. Please, can you explain further on either one way or 2-3 test?
Okay, thank you so much for that. Now, let me explain it by a simple example. Let's say, for instance, now a particular company that produces electrical bulb, they have the claim that if you buy this electrical bulb, it's going to serve you more than 5 hours. Sorry, more than 100 hours. That if you have a regular electric supply, this bulb is going to last for 100 hours. Now, you now want to check their claim whether the bulb is going to last more than 100 hours. You now take a sample of let's say, for instance, of 10 households that have bought that particular bulb. you now study them over time. So if that bulb is the lifespan of that bulb is more than 100 hours, it is called a one-day test. Why? Because you now have the direction that you are moving towards greater than, and anytime you are hearing the word more than, it is called a greater than. That means that the lifespan of that bulb will be greater than 100. Now let us now say, for instance, now you now just want to check that the bulb lasted for 100 hours. The bulb does not lasted for 100 hours. The bulb does not lasted for 100 hours. You don't know whether it does not reach 100 hours. Sorry, whether it does not reach 100 hours or it's more than 100 hours. You don't know. So, but you have two ways to move. It's either the bulb does not spend 100 hours or the bulb spend more than 100 hours. So in that case, when you now have two ways to move, it's either it is more than or it is less than, we call it two-day test. We call it two-day test. But immediately you specify that I just want to check whether this bulb is greater, the lifespan of this bulb is going to be more than 11 or more than 100 hours. You have what you are tending to already. You have what you are moving to already. So that in that case, it is called a one-day test. Am I clear with that, please, Mr. Osman Adamu?
Yes, please.
Okay, thank you. So any other question, please? Okay, Mr. Babafemi, please go ahead with your question, sir.
Okay, thank you very much. Sorry, I just wanted to shed more light on the multiple predictors. That's the regression analysis.
Please, sir, can you increase the voice?
Hello, can you hear me now?
Yes, I can hear you clearly, sir.
Is it better now?
Yes, sir. Yes, sir. It's better.
Oh, okay. So please, I'm just saying that, is it possible to explain the regression analysis again?
Okay, regression analysis.
Yes.
Okay, thank you. Thank you. Thank you. Now, regression analysis simply means that you want to predict your outcome based on your input or your independent variable. Let's say, for instance, now, I want to know the amount of the money I'm spending on electricity per year, because I want to predict in the next 5 years, I want to have a budget for electricity. Remember that the amount that I'm spending on electricity per year is the input that I'm going to put in my model to predict, oh, in the next 5 years, how much am I going to spend on electricity? Now, in regression model, we have several regression, which I'm going to a bit move higher now, so that for those people that they are doing, they are carrying their research on that particular aspect, maybe their master research or PhD research. So let me jump up a bit. Now, in regression, we have what we call simple linear regression. In simple linear regression, it simply means that you have one outcome and one predictor. That is, you have one independent variable and one dependent variable. That is, you are using one independent variable to predict one outcome. That is what we call simple linear regression. Now, we have what we call multiple linear regression. And remember, in simple linear regression that I'm talking about, if you have your dependent variable to be numeric, which is quantitative, and you have your your independent variable to be numeric, we can use simple linear regression. Now, if your independent variable is more than one, that is, you now have 2, 3, 4, 5 predictors, then you are going to use what we call multiple linear regression. We have what we call multiple linear regression. Take note of that. Now, let us now say, for instance, now your dependent variable is now categorical with a dichotomous value. Dichotomous simply means that you have two responses. It's either yes or no. It's either person has disease or not. It's either the diabetes is present or not. It's either the person has the HIV or not. Remember, the outcome now is now 2. And you want to predict factors that are contributing to someone having a type 1 diabetes or having a type 2 diabetes, or you want to predict you want to know the factor that contribute to high blood pressure or low blood pressure, or you want to determine the factor that contribute to someone being obese or not. then in that sense, there is what we call a logistic regression. In a logistic regression, the outcome is binary. Is either yes or no. Is either yes or no. So we call that a logistic regression. Now, there is another regression called we call when you have more than two, when you have more than one dependent variable. That is, your dependent variable is not more than one. You have 2, 3, 4, 5. There is what we call ordered logistic regression. Ordered logistic regression in handling that. There are a lot of regression. We have polynomial regression. That is your independent relationship between your independent variable and your dependent variable is no longer linear. Your x's are now carrying square. Instead of y is equals to x, you are now having y is equals to x squared, which is the quadratic, or you have y is equals to x cubed, which is the polynomial. We have what we call the polynomial function. Remember yesterday when I was showing us some graph, I showed us that we have linear curve, we have polynomial curve, we have the power curve, we have the logarithm curve, we have several curves. All these curves, they are embedded in regression. That is why the knowledge of regression is very, very important, because if you have a key knowledge of regression, you can apply it in many fields, because most of the data that we are dealing with can also be tailored to the regression. And then this is now, by the time they now look at this, they now check further. Is it there is what we call a non-linear data. By the time we now have a non-linear data, they now discover that all these simple regression can no longer handle it. They now migrate to what we call the lasso regression. Lasso and ridge regression are two key regression when we are talking about the machine learning. That's now when we now have the concept of artificial intelligence and then the machine learning. So all those ones are for the advanced. So regression is very, very good. And when you have the understanding of regression, you will be able to know, to predict the effect or the factor that is contributing to a particular outcome. I hope I'm clear with that, sir. Mr. Babafemi, sir.
Yes, thank you very much.
Okay, sir. Okay, sir. Any other question for me, please, before we move to the practical section? Any other question for me? So in the absence of none, I'm going to switch to my Excel now so that we can start. Let me load in my data. And please, this particular data I sent to the group. I think your memory, or the memory of your system is very, very strong, because we have almost 100,000 of data. So that data, I got that data from the Kaggle, which is an open source data on diabetes people. But we are going to be making use of some of the variable here for tonight's practice. And let me say this expressly, that we are going to touch all field. So because we are bringing data of health today, tomorrow you can see us bringing the data on finance. So please, the knowledge is still the same thing. You are going to the same knowledge. You are going to apply it in your field. So let me load in my data set. Okay, so let me stop sharing so that I can share my entire screen. Can you see my screen, my Excel? Can you see, please?
Yes.
Can you see it, please? Oh,
yes.
good.
Yeah.
Oh, good.
Yes.
Oh, good. So let's set the ball rolling. So if you look at this data set, I have gender, I have age, I have the what's it called, the hypertension, whether someone the person has hypertension or not, the age of that person. If it is 0, that means that no hypertension. If it is 1, it means that the person has developed hypertension. So This one is the heart disease. If it is 1, that means that the person has the heart disease. If 0, the person does not. And then we have the smoking status. 0 means that it is non-smoker, while 1 means that it is a punk smoker. The person smokes very well. So then we have the BMI. BMI simply means that body mass index. So we have the BMI of those participants. Then we have the hemoglobin A1C, HbA1c. It is called hemoglobin A1C level. They normally use it. It's one of the things that they normally check before they can conclude that someone is diabetic or not. So we have blood glucose level, the blood glucose level in the body of the participant. And then lastly, we have a column for diabetes. If someone is 0, so that means that that person is free from diabetes. And then if someone is 1, that means that person has developed diabetes. So it is very, very important for us to understand our key variable. Now, let's get down to the business. The first thing that I want to check here is that I want to compare the mean of the BMI with gender. I want to check whether as a female, you have the relationship between your mean, the mean of the BMI of female is also the same thing as the male. So I want to compare the mean of BMI between the male and female. You can also do it, okay, you want to compare the BMI between what? Between the men and the women. Remember now that the gender there is a categorical, which has 2 outcomes. It's either you are male or you are female. And then the BMI is the body mass index. For the male, we have it for the male, and then we have it for the female. So the first thing that you are going to do when you have such data is that you are going to group them. You are going to have the body mass for the male separate. You are going to have the body mass index for the female separate. Because according to the data that we're having here, they are together. They are what? They are together. So that means that you have to do the separation. And in this sense, I'm going to take it slowly. I'm going to take it slowly so that we can get it. So I'm going to take it slowly so that we can get it. Now, the first thing that you are going to do is that always try to put your data in the table format in Excel. How do you put your data in table format in Excel? Click any of the cell, any of the active cell that contain data. You can click this one, you can click this one, anyone. Then you will press Ctrl T. Ctrl T will make your data to be in the table format, which I'm going to do now. Ctrl T. Once I press Ctrl 3, you are going to see create table. So I want to create table for this my data set. Create what? Create table. Now, this one is going to show me the number of data that I have. If you look at this now, I have 100,000 of data. This is 100,001 because of the first one is the heading. So I have 100,000 of data, and then my table has header. Header are this gender, age, and some other things that we have. So once I click OK, then the content of your data is going to change. Then you will have them in table format. Do you get that concept before I move to the next one? Because we must get it tonight.
No, sir.
Do you understand that concept?
I don't get it, sir.
No, sir. Please come again.
Okay. Okay, let me take it again. Control Z, let me go back. Let me take it again. This is the data that we have. Now, what I want to do here is that I want to separate the BMI of male separate and then the BMI of female separate, so that I can be able to use t-test to compare them. Remember, I have the categorical variable. The categorical variable here is the gender, which is either you are male or female. Now, which is a categorical variable. The BMI is their number. Body mass is the index. They are numeric. So they are continuous variable. So remember that when you have a categorical variable, with 2 outcomes and then 1 quantitative variable, which is numerical variable. We normally use what we call t-test. We normally use what we call the t-test. Now, how do you now separate them? The first thing that you are going to do is that you are going to turn your data to be in table format. You are going to put all this data in table format. How do you put them in table format? Click any of the cell of your choice that are active. Click it, click it, click it, click it. So just stay on one cell, and then you are going to press Ctrl+T. Once you press Ctrl+T, it's going to create your table. By pressing the Ctrl+T, you are going to see the number of data set that you have, the number of rows that you have. You are going to have the number of rows that you have. Now, if you are looking at this, if you press the Ctrl+C, I have 100,000 rows of data. 100,000 is a very large data set, which is good for those people that want to build a machine learning, because machine learning model, they perform better when they have a large data set. So this data set is very, very large, 100,000 of data sets. Now, if you look at this now, header here, my table header means all this gender, age, hypertension, disease, heart disease, smoking status, BMI, hemoglobin A1C, blood glucose, they are called the header. Now, immediately I press OK, the containers of your data is going to change. That is, your data now is now in table format. It's now in form of table. Do we get that, please? Before I continue, can I proceed now?
You can proceed.
Yes, you can.
Yes,
You
sir.
can proceed.
Okay, I can proceed now.
Sir.
Oh, good,
Yes, sir.
good, great. We are getting it. Good. Now, you will now come to gender. Please take note, as a data scientist, as a data analyst, you must have what we call a code book. A code book is where you are going to be writing all your variables and then the number you are assigning to them. On my own code book here, one is representing male or men. So I'm using 1 in my code book here. 1 is male, while 2 is female from my own code book. So as you are coding it, as you are changing them to numbers, you have to have your code book so that you can go back to check what is 1 representing, what is 2 representing. So to make you a code, yes, go ahead.
Please,
sir, what is the code book? Where is it?
Code book simply means a book that you have for yourself to document what all your variables are representing. Like now, if you look at gender, excuse me, if you look at gender, in your own code book, you have gender. Under gender, you have male, and then you have female. Let us now say you want to code male as 1. You want to code female as 2. So you are going to have male as 1, female as 2. So by the time you are trying to interpret, you now be relating it that 1 that you are seeing here is representing male. 2 that you are seeing here is representing female. That is what I mean by the code book. Now, let's come to the heart disease here. In your own code book, you can assign that once that person does not have heart disease, I'm going to code it as 0. Once the heart disease is present, so that is where you are going to arrange it in your code book. In your code book. Now, for those people that are using data randomly, they can call it data dictionary. They can call it data dictionary, that you can go back and check what is 1, what is 2, what is 3, what is 4. And therefore, those people that are familiar with the NDHS is demographic health survey. There is what we call the sample manual. Sample manual is still the same thing as code book. That is where you are going to see all those variables that they have, what they are really talking about, what they are really representing. So code book is very, very important as a good data user, or as a good data analyst, or as a good data scientist. You have to keep your code book. So for all the work that I normally get from my clients, I have code book for them, so that they can come back tomorrow that, please, your 1 or 2 that you use in this, what is the meaning? I'll quickly go back to my code book and I will tell them this means this, this means this. I'm going to give room for questions. Please, I'm going to give room for questions. So let us now separate male BMI from female BMI. How do you do that? Please follow me. By the time you come to gender, you will see it like a funnel. Funnel here is like a filter. Once I click on that funnel, you will see another box, sort smaller to largest, sort largest to smaller, sort by color. We don't need that. Now, come back to under number filter. We don't need that. Now, but you are going to see select all. Can you see my screen? Select all.
Yeah.
Yes, sir.
Yes, we
Yes,
can
sir.
see it.
Okay. I just want to be sure that you are getting me. Now, I want to select only for male BMI. Only for male BMI. So, and in my code book, I know that 1 is for male. Then I'm going to untick order. Untick this, untick this. I'm going to leave only for male, which is 1. So immediately I press OK, automatically Excel is going to sort it out. The BMI that you are currently having here is the BMI for male only. And if you check it, if you check the gender, you will be seeing 1, 1, 1, 1, 1. You can't see 2 there again. I've already gave that command to Excel that I only want to extract only male. Only male. So by the time you do that, then once you click on the BMI, remember I want to extract only male out, only male BMI out. Once you click on that BMI, then it's done. Control Shift down simply means that I want to copy the whole BMI that's relating to male, and I cannot be using manually. I cannot be dragging it down like this, which I have, let's say 50,000 data sets. I don't have that luxury of time. So just come on, just click on the BMI. Immediately you click on that BMI, then you press Control Shift down. It's going to copy every BMI that relating to male, every BMI, instead of you dragging it yourself. So you have to work smart. So by the time you do that, then you are going to do Control C. Control C means copy. That is, after I've sorted this data, I have the BMI for what? For male. Then I want to pick it up. So I'm going to do Control C. In Control C, you've copied it. Then you will come back to where you have your sheet here. Which you what?
Please come again from this BMI.
Okay, from this BMI. Thank you. Control Z. Let me undo. Control Z.
I can't see the screen again, sir.
So, can you see my screen, please?
Yes, we can see your
Yes,
screen.
I can see.
Yes, we can see.
Your network.
We can see your screen.
Let me get network. Okay, so let me start again, please. Let me start it again because you have to get it. You have to get it. Let me start again. This is our original data. I want to introduce table. Once you click inside any cell, you press Control T. Once you press Control T, then you are going to press OK. Now we now have our data inside table. Remember, what I need here is the male BMI. I want to extract both male out and female out before I would not use them to perform.
It's not working like that for my own. No. It's just giving me header for the cell I click on.
Did you press Control T?
Yes, sir. Control T. It's not giving me header for the whole for the whole table. It's just giving me header for the cell I clicked on.
Can someone confirm for me? Can anybody confirm? If you are working with your, if you are with your system and you are with that data, can you confirm?
It's working as you are doing it, sir.
Like your,
Okay, it's working.
yes, sir.
Is it working? Okay,
Yes, sir.
Yes, sir, it's working, sir.
it's working.
Please,
Check for that
Yes,
person
it's
that
working at
complained
my
about
side.
it's not working. Please check. Please check. It's working. At least I have other system here that I'm using to monitor that. It's working. It's working. Please check. So by the time you have this, you have your data set inside table. Inside table. Now, you come to gender. By the time you press this arrow that look like a funnel, you press it, then you are going to have this. We only need for male, which I've coded as 1. Other one, you are going to untick it. I don't need it. I don't need it. So once you do the untick, then you press OK. Immediately you press OK, every data set that I go, they are just for the male. Then you click on the BMI. I want to copy BMI for me now. Once you click on BMI, please listen. Once you click on BMI, normally I supposed to highlight it down, but I don't have that luxury of time. I'm working with a large data set. It's not 10 data sets, or I'm working with 20 data sets that I can only drag down. We are working with 100,000 data sets, and that is the data sets that they will be giving you as a data science or as a data scientist. If you are working for a particular research company, they will be dealing with the large data set. So you have to work smart. So by the time you click on the BMI, then you will press Control Shift down. The shift down is the down arrow. You will look for down arrow. In your own system, you can see front arrow, back arrow, up arrow, and down arrow. So Control Shift down arrow is going to copy everything. It's going to highlight everything at once. Instead of you dragging your cursor from that, then you are going to copy it by using Control C. Control C is for copy. Control C is for copy. Control C. Control on your system is what we call the CTRL. The short form of control is CTRL. You can check your keyboard. You will see it there. CTRL. So once you do that, you've copied the data for the BMI for gender. For male.
Please let me get that again,
Any
sir. How
question
to
on
copy,
this?
sir?
Control C.
Please let me get
Control
out
C
to
is for
copy it
copy.
again. I couldn't hear the information very well, sir.
Yeah, hello. I think if
Okay,
we
let me go back.
Hello. Hello.
I can hear you.
If
Go ahead, I can hear you.
please, if we don't pause with the interaction, it's going to consume so much time. So I recommend we should pay attention and listen and follow the video later, please.
Okay. Thank you, sir. So that we can cover. I have a lot here that we need to cover tonight. So please just following me, and then you can get the video so that we can move on, please. Thank you for that suggestion. So by the time you do this, you've copied the BMI for male. Then if you come down here, can you see my cursor where we have diabetes sheet here? Can you see the cursor? Can someone confirm that for me? Can you see my mouse?
Yes, sir.
So if you
Yes, sir,
move
we can
next,
see.
you will see plus. You will see plus. Can you see that plus?
Yes, sir.
Can you see the plus? That plus means that you want to create new sheet. Once I click on it, it's going to create new sheet for me. So this new sheet, you can now come here and paste. Control V. Control V is for paste. It's going to paste it here. Then you can change the heading of this. You can change the heading of this to _male. So I'm having a male BMI now. This is not the male BMI for the male. This is not the male BMI. Let me mute everybody so that we can concentrate. Okay. This is not the male BMI. Now we want to do the same for female BMI. Remember, we have, I'm going to give him for question. Let me finish this, please. We have gender, which is male or female. and then we have the BMI, which is numeric. So let's go back to our data set again. Once you click on the diabetes, it's going to take you back to the data. And then I want to move up again. Control Shift up is going to take me back up. So we've done for the male. It's now remain female. Still come back to your gender. Once you click on that gender, then you will untick male and then you tick female. Remember, female is 2. You will untick male and then you will tick female, which is 2. Immediately you tick 2 and then you press OK. Excel is going to compute again the BMI for female. If you check now, we now have 2, 2, 2, 2, 2 for gender. So it's now female, 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 female. So automatically you have that. This one that we are doing is what we call data management. You are doing data extraction before you carry out the test, which is very, very important. Data management is a course on its own, which we are getting here now. Please take note of that. It's not all the information that you have inside your data set that you will make use of at the end. You have to know how to extract the one that is important and the one that is useful for you. So that is what we are doing. We are doing what we call the data extraction and data management. So by the time you have this, then you click on BMI again. Once you click on BMI, you press Control Shift down to copy. By the time you press Control Shift down, then you press Control C, you will copy the BMI again. You will copy the BMI again. So once you copy the BMI again, then come to the sheet one that you've created. Once you click it, then come to the first one, which is column B, and you press Ctrl V. Once you press Ctrl V, it's going to paste it. Then you can edit this. This is now for female. You now have the BMI for male, and then you have the BMI for female now. You can now do what we call the t-test to compare the two. Let's quickly compare the two together, and then I'm going to give room for questions before we move to another test. Now, remember to check whether your Excel is ready for data analysis. Once you click on data here, you must see data analysis. Once you click on data, you must see what? You must see data analysis. Now, in data analysis, once you click on data analysis, Excel is going to open several things that you can do with data here. But we want to carry out what we call...
Sorry, sir, please. Can you come again? I didn't get what you just said.
Where should I come again?
This data analysis.
Where should I come again? Where?
This particular data analysis that I just did now.
Okay,
I don't understand what.
Let me go back. Let me go back. Once you open your Excel, you will see our data here. Immediately you see data, you click on that data. Once you click on that data, at your right corner here, you must see data analysis, which is going to show analysis. So that means that your Excel is ready for data analysis. Did you get that, please? Did you get that? I need no reply. Did you get that?
Yeah.
Okay. So once you click on that data, your Excel is going to show data analysis. If your own is not showing data analysis, so that means that you go and check yesterday's video on how to set your Excel for data analysis. So once you click on data analysis, then you are going to see several tests here. But the test that we want to use is we have two samples, the male and then the female. Then you can use, it depends on you. It depends on you because we have assume equal variance or assume unequal variance. Assume equal variance in statistics, we call it homogeneity of variance. That is, we assume equal variance for both male and female. And then when you assume unequal variance in statistics, we call it heterogeneity of variance, but it's beyond this class. So just pick unequal variance. T-test, two sample assuming unequal variance. Once you click on it, once you press OK, it's asking you, supply me the range for the first one, which is the male BMI. Now you are going to press, you are going to put your cursor on the first A2. We have A2. Remember, column A is for mail, and then the data starts from A2. Once you click on A2, you will see that it is active here. We have $A, $2. So that means that you are on A2 cell. A2 cell. So once you have the A2 cell, to not get down the other one, instead of you dragging it down, you don't have that time. You have to work smart. Just press Ctrl Shift down. Once you press Ctrl Shift down, it's going to take everything. In this data set for mail, we have 58,553. 58,553 for male BMI. So you move to the next one again, which is now for the female. Then you can drag this up so that you can quickly get to up. Then you are going to press B2 cell to make it active. Remember, the column B is for female. The column B is for female. So by the time you press the first cell here, which is B2, you are going to see it here that it is active. $B, $2. So that means that it is active.
Hello, sir.
Then you work smart again.
Hello, sir. Your cursor is not moving, so
Go ahead.
I'm not following what you
My
are saying
cursor is not
because your
moving.
cursor is not moving. Yes, please.
My cursor is not moving.
It is moving. No,
Check your network.
it is
Moving
moving.
here.
Please check your network. Please check your network. The cursor is moving. Please. Okay. So by the time you press this, the cell is going to be active. Then we still work smart again. Control Shift, down arrow. So for the female BMI, we have 41,431. 41,431. By the time you do this, then alpha is 0.05. This is what we normally compare with. Alpha is the threshold that we normally compare with our p-value to now check whether to accept the non-hypothesis or to reject the non-hypothesis. I'm going to explain that when we get to the result. So once you have this, then you press OK. Immediately you press OK, Excel is going to create another sheet for result. Another sheet for result. So variable 1 here is the male BMI. BMI underscore male. While the variable 2 here is BMI underscore female. BMI underscore female. So before I go into the interpretation of this, any question for me, please? If you have question now, you can just raise up your hand and then I will attend to it before I go into the interpretation. Because you need the knowledge of theory to interpret practical. So that's why theory too is very, very important. Any question, please? You have the floor. You can let us just use 5 minutes to quickly answer a question before I interpret this. If you have a question now, you can raise up your hand. I will call you. Okay. Let me take it one by one. Please, let me take it one by one. Okay. Adamo Ishola. Adamo Ishola, can you ask your question?
Sorry, sir. I was complaining about the cursor not moving. That was why I raised my hand. Sorry.
Okay. Check your network is moving. Okay, Comfort, please go ahead with your question.
Hello, sir. Is it possible for us to have this recording?
Comfort, please go ahead with your question.
Yes, sir, I'm talking.
Good evening, ma'am.
Is it possible for us to have... Good evening, sir.
Okay.
Is it possible for us to have the recording of this practical class? Because I didn't see the one for yesterday. Hello, sir.
Are you on the group? Are you on the group?
Yes, sir. I'm on the group, sir.
If you're on the group, the link there for yesterday and day before yesterday, once you click on that Google link, you are going to, it's going to take you there. And let me say this too, they are checking my back end for me so that they can allow you to download. Initially, we did, because our previous classes they don't use to download. They just go there and watch. But now that you requested for download, they have to check it at my back end, and then they will sort that one out. So once you click on that link, it's going to take you there. Or maybe if I drop the link, I'm going to highlight it that this is for the recording video. So we're going to do that. Thank you.
Thank
you,
sir.
Arowolo, please go ahead with your question, please. Arowolo.
Okay, sir. Sir, I want to ask about where you talk about data analysis, that we are going to click on data. I cannot see the data analysis on my. What I saw is.
Please, can you increase your volume?
When you talk about we clicking on the data, I will click the data that we are going to see data analysis. I can't see that on my system here when I'm using.
That means that your Excel is not ready for data analysis. So that means that you have to set it to ready for data analysis. Yesterday, we taught that yesterday. So you can visit yesterday and look at it. Okay. The two Adebayo. Okay, let me take it one after the other. Emmanuel Adebayo, go ahead. Emmanuel Adebayo.
Yes, good evening, sir.
Yeah, evening.
Yes, sir. I wanted to ask, is it possible, because I know we have a lot of time has been spent, but I don't know if it is possible for you to go over the because my network logged me out of the of the class, so I'm stuck at the BMI where you open the new sheet. So I don't know if it's possible, if you can spare some minutes to just recap the whole thing, so I can
I'm going to use another example. Example which you can apply the knowledge on the BMI. So let us go back to BMI again. I'm going to use an example from the data. Okay. Right. Adebayo Ismail, please go ahead. Adebayo Ismail, please go ahead with your question.
Thank you, sir. Thank you, sir. How you were able to pick the analysis? I couldn't see it on my system here, and I've already set my Excel to be ready. But I don't know where you actually saw that analysis.
And then did you see data analysis on your Excel?
Has been, yes, I've already done that based on what we did yesterday.
So once you click on data analysis, there it's going to open it for you, and where you can also pick the type of test that you want to use.
I didn't see data analysis. Where will I see that, sir?
By your right hand. Once you click on data, look at your right hand side corner. You will see data analysis. So once you see that, so that means that your Excel is ready. Look at my own. Look at my screen.
I only saw data validation. Okay.
No. Click on data. Once you click
I couldn't
on
see
data,
your screen. No, it's not showing from my side yet.
Is your network? So is your network?
I'm only seeing data validation.
Don't worry, we're going to look at that after the class. Let's look at that after the class.
I'm only seeing data validation here.
Please take note of this.
Analysis?
Please take note of this. Let's interpret. We are going to look at that after the class. So let's proceed, please. Now, we have the result. How do you interpret this result? Remember, I told us that the first thing is you want to describe your data.
Hi, Mr. Ojo. Are you still there?
Then the variance is this, but we need standard deviation, which is the square root of the variance to get the standard deviation. Can you hear me, please?
Yes,
Please
sir.
come again.
Can you hear
It
me,
was
please?
breaking, sir. It's just
Okay.
now we're hearing you. Yes, sir.
Okay. So now the hypothesis is this. In hypothesis, we have what we call the known, and then we have what we call the alternative. We have what we call the known, and then we have what we call the alternative. The known hypothesis here is that there is no difference between the male BMI and female BMI. There is no difference between them. That is, if you are picking a male at random and you check the BMI, and you also pick a female at random and you check the BMI, there is no difference between them. They are all the same. Now, the alternative hypothesis will now tell you that there is difference. That is, the male BMI is different from the female BMI. Remember, hypothesis is the claim that is not yet verified. Now, based on the data set, now we now want to check whether there is difference or there is no difference between the mean of BMI for male and female. How do we check this? By the time you look at the T here, you will see critical, you will see 1T test, you will see T critical for 1T test, you will see 2T test, and then you see T critical for 2T test. Now, the P that you are seeing here is what we call the probability value. We call it P value. P value. I'm typing it on my Excel so that we can see it. We call it P value. It is called probability value. It is this P value that we normally compare with the alpha value. Alpha value is what we call the level of significance, which we normally take to be 0.05. That is what we normally compare with. Now, if you look at this P value here, the P value here is 1.3452 times 10 raised to power minus 13. The E that you are seeing here is the raised to the power. The raised to the power of minus 13, which is the same thing as we have 0.20, then 1245. Let me take it again. 1.24521 E raised minus 13. It simply means 1.245 raised to the power of minus 13. How do you express that in decimal? It simply means 0. Then you type 12 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then you have what? 1, 2, 4, 1, 2, 4, 5, 2, 1. That is the value that you are seeing here. This value that you are seeing here is this. Can you see now that immediately I remove my console, it brought out this. So that is the meaning. So if you compare this now with 0.05, it is less than 0.05. That is, the P value that you are having here is less than 0.05, which is the standard. Now, immediately it is less than 0.05, you are going to reject the non-hypothesis. Remember, I've stated our non-hypothesis that there is no difference between the BMI for male and BMI for female. And then the alternative hypothesis will not be there is difference between the BMI for male and BMI for female. How will I now know which one should I go for? By the time I now compare the value, the P value that I'm having here, with the level of significance, which is 0.05, that is, immediately this is less than 0.05, we are going to reject the non-hypothesis, reject the non-hypothesis, reject the non-hypothesis, reject the non-hypothesis if the p-value is less than the alpha value, which is 0.00, which is 0.05. So immediately you now do the comparison and you now see that this value 0.05, which is the alpha value, then we reject the claim that the BMI for male and female are what? Are different. What are different? Remember, the non-hypothesis is that the BMI for male and female are not different. But the alternative hypothesis is that the BMI for male and female are different. So if you are writing paper or you want to submit it for publication, anybody checking your paper will not serve as literature review for them that based on Tolulope et al. 2025 research or his research of what have established that the BMI between male and female are not the same. Or Jackson 2024 et al. Has proposed that the BMI for male and female are not the same based on So based on the result that you have from here. So that is for this. Now let's move further, please. The next one that we want to do now is we want to compare between blood glucose and then the diabetes. Let's go back to our original data set. If you look at our original data set, let me go up, control shift up. If you look at our original data set here, we have 0 for those one without diabetes. And then we have 1 for those with diabetes. Now, we don't want to check, excuse me, please. We don't want to check the blood glucose between diabetes and non-diabetes are the same. The non-hypothesis will not be the blood glucose between diabetes and non-diabetes are not the same or are different. Then, excuse me, then the alternative will go way around that. The mean of blood glucose between diabetes and non-diabetes are what? Are different. The none is are not different. The alternative will be are different. Now, let us do the same thing. For Mr. Adebayo Ismail and then for Mr. Adebayo Emmanuel, please look at it again. We want to sort this out the same way we did for gender. Remember, we have 2 outcomes now under diabetes. Either it is that you are someone is diabetic or non-diabetic. If it is diabetic, it means it is 1. If it is non-diabetic, it means it is 0. Now, I want to bring out first those one without diabetes. Those one without diabetes. Now, immediately you click on this something like this filter, you are going to see 0 and 1. 0 is for non-diabetic, while 1 is for those that are
We can't hear you.
So we cannot hear you.
So we can't hear you
that are
again.
diabetic.
So we cannot hear you from that select.
Can you hear me now?
So we cannot.
I'm waiting. I'm waiting. Can you hear me now? If you can hear me, let us move on. If you cannot hear me, I'm going to wait. Can you hear me now?
We can hear you.
Yes, sir.
We can hear you.
Okay. You can hear me now. Please confirm again.
We can hear you, sir.
You can be heard, sir.
Okay. So let me go back again. So let me take it again. Now we want to extract the blood glucose for those that are non-diabetic. That is those one with 0. By the time you click on this filter, you will see 0 and you will see 1. You will untick 1. Immediately you untick 1, you are left with 0. So by the time you press OK, the Excel is going to give you only the blood pressure for those that are non-diabetic. For those that are not that are non-diabetic. So to get that, and then you follow the same procedure. Once you click on the blood glucose level, you that arrow, then you will copy the same way we did for gender.
Excuse me, I don't think you went back.
Okay, I'm with you.
Network is breaking.
Your
network is breaking.
You didn't sort out the gender.
You said?
You still went. You didn't sort out the gender.
Okay.
Can you hear me?
Okay. I can hear you.
Yes,
okay,
you didn't sort out gender.
Let me go back.
It was showing only female.
Okay. I didn't sort out the gender.
Yes.
Okay. Thank you for that. Thank you. This shows that you are really following me. Thank you. So let's go back and replace. Thank you for that. So let's go back and take this, and then we take this, then we, okay. So we now have our data back. Thank you for. You still hear me, please?
Yes, please.
Can you hear me, please?
It can be heard.
Okay. Okay, please, I just want to confirm so that we can be on the same page. So once you press the filter here, then okay, we've done this already. Let me go back so that I have the original data. Then let me now what? Let me untick one. Once I untick one, I press OK. Immediately I press OK, then you come to the blood glucose level. Once you click on blood glucose level, then you press Ctrl-Shift down. Immediately you press Ctrl-Shift down, then we copy. Then once you copy, you can also come back here. The sheets that we have already, sheet 1. Excuse me. Then you paste. Then you paste. So Ctrl-V. So here you can now put mail. Underscore mail. Can you still see my screen, please? I want to confirm whether we are still on the same page. Please confirm from your end. Can you see my screen?
Yes, sir.
Okay. So we are through for the male.
But sir, we pick for
so let's quickly
both
do
gender.
For the female. Sorry, we are done for the diabetic. Hello, I'm listening.
Yeah, yes, we pick for both genders, sir. When we are trying to copy our data from the main data, we pick for both gender. You know, we have already changed our gender back to both male and female.
We want to check the blood, the glucose blood level of someone with diabetes or without diabetes. We are done with gender. So our focus now is on the variable called diabetes. Mr. Bamidele, did you understand that?
Yes, sir.
So we are done with gender. Our focus now is on diabetes. So now let's go back. We are done with the male. Then let's go to the female now. Sorry, we are done with those with diabetes. Sorry for that. We are done with those with non-diabetic, which is 0. Now we want to check for those with diabetic, which is 1. So we come back here under diabetes. Then you are going to tick 1 and then you untick 0. You are going to tick 1 and then you untick 0. So once you do that and then you press OK, it's going to produce glucose blood glucose level for those with diabetes. For those with what? With diabetes. So by the time you click on this now, you press Ctrl-Shift down. Once you have Ctrl-Shift down, then you press Ctrl-C. Ctrl-C will copy the data. And then you go to where you have the sheet. Then you press Ctrl-V. By doing that, then you can now put female for this. Female. Are we still together, please?
Sir, are we dealing with the blood levels of females and male, or blood levels of diabetic patients and non-diabetic patients, sir?
We are dealing with blood level of diabetic patients and non-diabetic patients. The diabetes is not our variable now that we are dealing with.
Yes, sir.
Did you get that, please?
I got that.
The other one that we did, we consider.
But you kept mentioning male and female. So that is why I called your attention to that, sir.
I've corrected myself. I've corrected myself. So it's diabetic and non-diabetic. Did you get that, sir?
Yes, sir.
Did you get that, sir? Okay. So by the time we have this, then you can now do the comparison of the blood glucose level for both diabetic and non-diabetic. For both diabetic and non-diabetic. So by the time we click on data analysis, then we have this again. Two sample, assume equal mean. Okay. So you clean this. Remember, the column for a non-diabetic is C2. We're starting from C2. Once you click on that C2 cell, then you press Ctrl Shift, then the down arrow is going to copy. So for those with non-diabetic, we have 91,501. 91,501. Those with no diabetes. So now, let us now go back and also fix for those with diabetic. Once you click on the D2, then you press Ctrl Shift down. So for those with diabetic, we have 8,501. 8,501. Then you can now press OK. Once you press OK, you are going to see the results. You are going to see your results. So you can now change this one to the blood. Let's say I have blood glucose level for the diabetics. And then for this one is blood glucose should be G, sorry, glucose level for non-diabetic. Let me change this one to G. Okay, so based on the understanding that I have explained for our gender, can someone interpret this for me, please? Let me now see whether we have the understanding of the interpretation now. Please check the p-value. The p-value for the two tests here is 0. Then what will not be the conclusion? Anybody, please? If you want to give me the answer, you can raise up the hand. Anybody, please? Hello, can you still hear me? Are we still together?
Yes, we can hear you, sir.
Yes, we can hear you.
Okay. Can you look at this and let's interpret it? Okay. Go ahead. What will be the interpretation? Okay, I can see P is less than 0.05. Osman Adamu, can you speak out?
Yeah, you would have to reject the alternate hypothesis.
Okay.
In other words, you accept the
Mr. Ibrahim Yusuf.
it.
Okay, Mr. Ibrahim Yusuf. Can you speak now? Okay. Mr. Rolo, I want to let me take like two results more, two interpretation more. Mr. Rolo, please go ahead.
I checked the hypothesis if the p-value is less than level of significance. Both p-values,
Okay.
Both
Okay. Good. Okay. Okay. Madam Comfort, let me hear from you.
Yes, sir. The p-value is less than 0.05. That means you are rejecting the null hypothesis.
Yes. Hypothesis. Oh, good. Now, Let me now make one correction, please. That is why I asked you to interpret it. You don't accept alternative hypothesis. We base our conclusion on non-hypothesis only. Once you reject the non-hypothesis, you just conclude. Don't say you accept the alternative hypothesis. If you put that in a peer-reviewed journal, they are going to reject it for you. Or you want to publish it in a Lancet journal or the PMC journal, they are going to reject it for you. Please, you don't accept the alternative hypothesis. So once you reject the non-hypothesis, you now what? You make your conclusion. So that means that the blood glucose level between diabetic and non-diabetic patients are different. Do we get that, please? Mr. Adamu? Okay, thank you. So let's move further, please. Let's move further. Now, another test that we're going to be looking at is the correlation test. We want to check, is there any correlation between the BMI and hemoglobin A1C level? After this class, you can play around the data, check those variables, and then you start practicing it on your own. We set the foundation, but it's not left for you to build on that. So let's just move to the correlation, please. Remember, I told us that before you find correlation, it must be two. It must be what? Two continuous variable before you can use correlation. Now, in using correlation, we want to find, is there any correlation between BMI and this hemoglobin A1C? This is HbA1c level. Is there any correlation? Your own, you can take a variable from your field, which is continuous variable, and then you want to check whether there is a relationship between them. How do we do that? Once you click on data analysis, you will see aspect called correlation. Let's go up. This is correlation. Once you click on correlation, it's asking you for the range. Which one do you want to check? We want to check the BMI and hemoglobin A1C level. We want to check the BMI and hemoglobin A1C level. So once you click on the first cell, which is this F2, row F is for BMI, while row G, column F is for BMI, while column G is for the hemoglobin A1C level. So by the time you just drag the cursor to the first, the 4 cell for G2. Now we now have F1 and G2. F1 and G2. Once you have that, just press Ctrl-Shift down. Once you press Ctrl-Shift down, it's going to capture the entire data. It's going to capture the entire data. So then you press OK. Once you press OK, you are going to see the result of your correlation. Let me show you. So the first column here is the column of BMI. We have BMI. This one is like your 2x2 table. And then this is the HbA1c. And then here we have BMI to BMI. The BMI, let me change this to I. This is I, BMI. And then we have my hemoglobin A1c, HbA1c. HbA1c. So let me change this one to 1. HbA1c. Now, if you look at this, are we still together, please?
Yes, sir.
Yes, sir.
We are together.
Okay, good. Okay, good. Now, if you look at this, whenever I have BMI and BMI, I'm going to have 1. This is what we call a perfect correlation. Let me quickly tip in some statistical concepts here. Correlation value, correlation take its value from -1 to 1. It takes its value from -1 to 1. That is, correlation value range from -1 to 1. When it is positive 1, when it is 1 like this, it is called perfect positive correlation. That is, the correlation between the two variables are perfect. Perfect, which is not real in real life. So it's because you are comparing, you are correlating two things. You are correlating, let's say you are correlating father to father, the same thing, the same BMI, you are comparing with the same BMI. They are going to have a perfect correlation, because when you have 2, you still have to, let's say you have 2 in row 1, you have 2 in row 2, you still have 2 in the other one too. So it is called perfect. So the one that we normally check is the one with the hemoglobin A1C and the BMI. That is why if you are plotting, if you are checking for correlation, the diagonal, the right diagonal is always perfect, because BMI and BMI, hemoglobin A1C and hemoglobin A1C is also 1. But what we need here is the correlation between the BMI and then the hemoglobin A1C. And then the correlation here is 0.082. Now, we have range for the interpretation, which I'm going to give us tonight. And as I'm saying it, I'm going to be typing it on this Excel sheet, so that by the time you are going through this video, you are going to see it. So any value from 0.75, please take note of that. Those are the things that you are going to be using when you are doing the interpretation. Now you have the result. How do you interpret it? Any value from 0.05 to 0.99, it is called strong positive correlation. It is called strong positive correlation. Positive correlation. It is called strong positive correlation. Any value from 0.5 to 0.74, it is called positive. It is called positive correlation. It is called positive correlation. Now, any value from 0.0, let's say 0.1 to 0.49, it is called weak positive correlation. That is, the correlation, the association between them, although it's positive, but it's weak. Now, if you have your value to be equals to 0, it means that no correlation. No correlation. So that means that the two variables that you are trying to check, they don't have anything, they are not relatable. Let me put it like that. So the same thing goes for the minus. Anytime you have this minus, it's going to be strongly minus, strongly negative correlation. It's going to be strongly negative correlation. If it is minus 0.5 to minus 0.74, it's going to be negative correlation. If it is minus 0.1 to minus 0.45, it's going to be weak negative correlation. So the same thing go with it. So with the understanding now, can anyone interpret what is the correlation between hemoglobin A1C and BMI? What is the interpretation? What will be the interpretation? Anybody, please? Remember, the correlation value that we're having here is 0.082. What will be the interpretation?
There's a weak positive correlation between them.
Between what?
A weak positive correlation between BMI and hemoglobin value.
It was. Thank you so much. So So it means that there is a weak positive correlation between the BMI and hemoglobin A1C. So another thing that you are going to do, because of our time, because I'm still going, we still want to check regression. You know, we started 7:15, so we're going to spend our 2 hours. We started 7:15. Now, for your own, you are going to check the correlation between blood glucose and age. You check it at your own convenient time using that data set. You check the correlation between the blood glucose level and age. Is there any correlation between the blood glucose level and the age? So if there is correlation, what type of correlation? And then you are going to interpret it. And then you are going to interpret it. So please make sure you have the understanding of this. I think last 2 weeks I run an analysis on this. Someone in, is it part 2? I don't know the name they normally call it. After they are through with their MBBS of 18, they go for house. Is it house resident? They now have part 2 exam. So they have to spend house what? Help me, please.
Housemanship.
Then they will now go for residency. They will now go for residence exam and some other things. They rejected the paper of that person because it did not indicate the correlation. So we have to plot the correlation and find out residency part 2. Thank you. Residency part 2. So they have to reject it, and they told him to go and look for a biostatistician or a good data scientist to look at it. So it's just because of correlation. We just calculate the correlation and I interpreted it for him, and they accept the stuff. So it is very, very important. So please, it's very, very important. So by now, if you are also in that shoe, you should be able to do it yourself instead of looking for a biostatistician, so that you will not use work to what you will not put more load on biostatistician. So that is why I have to train people on how to do this, which is very, very important. Now, lastly, we want to look at the regression. We want to look at what regression. And then in looking at the regression, I want to predict the blood glucose level based on age, BMI, and hemoglobin A1C. Remember, when you have more than one independent variable for your prediction, it is called multiple linear regression. It is called multiple linear regression. So I'm going to do the hardest one, which is the multiple. Then I'm going to leave you to go and do the simple one. Now, let's go back to our data. Let's go back to our data. Control Shift up. Let me go back to up. Now, my variable, I want to use BMI, I want to use age, and I want to use hemoglobin A1C. Okay, let me pick it from age. Let me create another cell for them. Control Shift down. I want to copy the age, and then let me go to cell 1. Cell 1, Control V. I want to have my age there. The second variable that I want to use is the BMI, the body mass index. Let me go back. Where's my BMI? Let me go up, Control Shift up. Then I go to BMI again. Control Shift down. Once I have Control Shift down, then I copy it. Copy. Once I have the copy, then I go back to my sheet 1. Then I paste it there. So that is what we call data extraction. So I have then the next one is we need hemoglobin A1C. Hemoglobin A1C. Now go back to your data, Control Shift up so that I can get to the top again. Then click on, okay, hemoglobin A1C level, Control Shift down to copy everything, Control C. And then I come back to my to my sheet 1. Then I paste. Now, these are the variable, these are the independent variable or explanatory variable. or predictor for what? For the oh, sorry. Okay, I can still use this set. Let me just use this set. Continue like that.
Sorry, sir,
Okay.
please, I have
Now let me go and
a-
bring the.
I think for the diabetes, we're
don't-
still giving those that do not have diabetes. We've not filtered it yet.
Okay. Oh, let me check. Let me check. Sorry. Let's check, please. Let me undo and let me check. Thank you for that. I think we have it already. Please look at it. We have them already. We have them already. I think that was the first thing I did when I came back. So we have them already. Are we together now?
Yes, sir.
Okay, we have them already. So age, let me go up here. Excuse me. So I have the age, Control V. Then the next one is the BMI, Control Shift down, then copy.
Can you just try and
Then we
use
have
Control Y, sir?
Control
Y, so that you can
Control
return
what?
what? Control Y. It will return what you've deleted before. It will return it back. It's like a redo.
Oh, okay. No problem. We're almost done. Then we have the hemoglobin A1C. We have the hemoglobin A1C here. And then lastly, we have the blood glucose level. Then we have air to be blood glucose level. So we have our variable. So blood glucose level is our outcome, which is dependent variable. Age is one of our explanatory variables, is one of our predictor. Then we have BMI, and then we have the hemoglobin A1C. So to analyze this now, you come to data analysis. Excuse me. We come to data analysis, then we look for regression. This is a regression. Once you click on OK, it's asking you input Y range. Y here is the dependent variable. So once I click on the first cell, then Control Shift down, I have the other. So I have input for Y. Then I want to put for X now, but I have more than one X. So I have more than one predictor. So once you click on the first one, then just extend the cell to this. So I have this. This has captured the three predictors. Then Control Shift down, then we have all of them. Now, let us take this one after the other. The confidence interval, we need it. Then we have the residual. Residual is the error plot, but let me just, by the time we get to the R and SPSS, I'm going to explain more on the residual plot. But let me pick the probability plots. Then we have the standardized error and some other things. So let me click OK now. It's going to take like 2. Okay. So we have this now. We have this output. Can you see my output?
Yes, sir.
Yes, sir.
Okay. Now, good. Now, this is what we call the regression statistics. I'm going to be taking it one after the other, and I'm going to be interpreting it. You have the results now. What is now the interpretation? The first thing that you are seeing here is what we call the regression statistics, where you have multiple R, and then we have the R square. Remember yesterday when I was trying to plot two pre-test and post-test, when I show you a scatter plot, I also put a regression, I also put equation line on it. which I interpret then with the R square. The same thing goes for this. We have R square and then we have adjusted R square. Adjusted R square in model, we normally use adjusted R square for interpretation, because adjusted R square would have taken care for the random error that may be in your model. So our adjusted R square, which is the R2 square, adjusted R square is 0.039. Remember, I told us that the R square is expressed in percentage. So by the time we multiply this by 100, multiply 0.039 by 100, we're going to have just 3.9%. We're going to have 3.9%. 3.9%. What is the interpretation of this? What is the interpretation of this? Now, this was simply telling us that
Excuse me, sir. Can you explain that again?
The what? The R square, right?
Can you that again, please? Yes, sir.
Okay. Now, if you look at our output here, we have regression statistics. Under the regression statistic, we have multiple R square. We have the R square. We have adjusted R square. Adjusted R square is what we normally use. When you have both R square and adjusted R square, we normally interpret adjusted R square. But in the situation whereby it is only the R square that you have, you interpret it only. Excuse me. Now, R square is interpreted in percentage. That is the result that you have here. You have to multiply it by 100. By the time you multiply this by 100, multiply 0.039 by 100. Let's mute our mic, or let me mute everybody. Let me mute everybody, please. So, by the time you multiply this 0.9%, you can do it. Multiply this by 100. It's going to give us 3.9. So what is now the interpretation of this 3.9? It means that out of the total variation, remember, variation in Y, which is the outcome, is 100. We are talking about 100%. Out of the total variation in Y, our explanatory variables that we have, the BMI, the age, the hemoglobin A1C, only contribute 3.9% to the outcome. The contribution of blood glucose level of both the three predictors were just 3.9, very, very low. It means that there are some key variables that contribute to blood glucose level, which is not captured in this data. That is, you are going to do further research by checking literatures, by checking journals. What are the other variables that contribute to the blood glucose level? Because according to this data that we have now, we have age, BMI, and hemoglobin A1C. They only contributed 3.9% out of 100%. So that means that you have to do further research and check literature. Remember when I was trying to explain how do you select your variable? One of the key things is that you have to check literature and seek for the expertise. Those that are specialized, clinicians that are specialized in this area. You can ask them, what other variable do you normally check in getting that can determine blood glucose level? Because looking at this now, this one, the three variable can only explain 3.9%, which is very, very low. The remaining percentage are those variables which is not included in this model. Am I clear with that, please?
Yes, sir.
Am I clear with that?
Yes.
Okay,
Now,
good. The next one that you are going to see is the ANOVA table. ANOVA table, I'm going to give room for question. Let me interpret everything finished so that I can answer the question once. ANOVA table that you are seeing here is, please move to the mic. Okay. Let's continue. The ANOVA table that we are seeing here is explaining the significance of the regression. That is why when they can ask, okay, in regression to check the, I want to remember the name that they normally call it, regression significance, we normally use F-test. If I still remember, there is a terminology that we normally call it in statistics. I can't remember for now, but if I remember, I'm going to. So by the time you check this regression, model adequacy, if you want to check the model adequacy, whether the model is significant or not, we normally use F-test to confirm that. Model adequacy. Yes, I remember. Now, if you check this, what you are seeing here is what we call the, you will see significance of F. The significance of F that you are seeing here is the p-value, which is 0. It is this that you are going to compare with the alpha, which is 0.05. Immediately this one is less than 0.05. It means that the model is statistically significant. It means that the model that you just have, what is that? The model, the outcome is the blood glucose level, and then the predictors are what? The age, the BMI, and hemoglobin A1C. The model is significant, although those predictors are not really explaining, are not really contributing to the outcome of the blood pressure, to the outcome of blood glucose level, but the model is significant. If they are asking you, what is the significance of this your model? This model is significant because when you check the value of the p-value for the F significant, we have 0, which is less than 0.05. That means that the model is significant. That is the essence of this ANOVA table that you are seeing here. Now let's go back to the real work. Now remember that in our model we have y. Y is the dependent variable, which is our what? Which is our blood glucose level. Blood glucose level. Then, which we now equals to, is equals to the first model, the first equation. We have the intercept. Remember, I showed yesterday too. Our intercept here is look at the coefficient. You will see coefficient. Let me expand this. Under the coefficient, you will see some value. For coefficient, we have intercept. The intercept here is 90.94. I'm going to interpret. I want to write the equation out, the model. I want to write it out from this. Then I will now interpret it. Then plus, for the first variable that we are seeing here is called the variable age. Remember, the first column is the column age. So the coefficient for age here is 0. What? We have 0.1. Let's say 1, 3, let's say 1, 4. Let's put to the 2 decimal. 1, 4. If you approximate this to 2 decimal, this is 9. You approximate this is going to be 1, 4. Then we have what we call age. We have variable age with it. Plus, the next one is our what? Our BMI. The coefficient of the regression coefficient for BMI here is 0.32. Then we have what? We have BMI. Then the last one, which is the last one is the hemoglobin A1C, which is 5.88 what? 88. 5.88. Then we have HB A1C. Can you still see my screen, please?
Yes, sir.
Yes, sir.
Okay, good. Okay, good. Okay, good. Let's go back, please. We are going to round up now. Now look at this equation. So if you run this particular analysis, they can ask you what is now your predictive model. This equation that you are seeing here is now the new model that if you supply me A1C value of any random person, supply me the BMI of any, let's say for instance, I pick one person at random and I measure the BMI, I measure the hemoglobin A1C of that person, and the person give me the correct age. I can predict what will be the blood glucose level of that person. Now, how do you now interpret this model? This is now your predictive model that you can use. If this one is in marketing, you can use to predict the sales. If this one is used in agri, let's say you are modeling this in agri, you can use it to predict the yield of crop. If this model is using, if you are using this model in engineering, you can use it to predict the lifespan of a particular engine. So how do we now interpret this? We are going to interpret this one by one. The first thing is that when all your predictor is equals to 0, when all your predictor, age is equals to 0, BMI is equals to 0, hemoglobin A1C is equals to 0, the blood glucose level is going to be 90.94, which is not true in real life. What did I mean by that? At 0 age, they've not even given birth to that person. How would the person that are not yet gave birth to having the blood glucose level of 90.94? Those are the things that we normally see when the quack analysts are doing the interpretation, because they will just give it to AI, and AI will interpret it for them that at age 0, the glucose level is going to be 90.4, which is not making sense in the real life, because someone that is not yet born, you have the blood glucose level to be 90.4, which is not supposed to. So at that point, we don't interpret the intercept alone. You don't interpret the intercept alone, because at age 0, the person is not even alive. So let us move to the age. The value of age is 0.14. The regression, the coefficient of age is 0.14. What did I mean by that? How do we interpret this? It means that a unit increase in age, that is, as you increase yearly in age, the result of your blood glucose increased by 0.14. Let me take that again. As you increase in age, the level or the blood glucose level increased by 0.14, provided that all other variables are kept constant. That is, when BMI is constant, when hemoglobin A1C is constant. A unit increase in your age will give to 0.14 increase in the blood glucose level, provided that all other variables are constant. That is for the age. Let's move to the BMI. It means that a unit increase in your BMI level is going to increase your blood glucose is going to increase by 0.32, provided that all other variables are kept constant. Let me now go back to hemoglobin A1C. It means that a unit increase in your hemoglobin A1C we give 5.8 increase in your blood glucose level. So that means that you have to watch your hemoglobin A1C, because the coefficient is very, very high, 5.88. Let us now say, for instance, someone with hemoglobin A1C of, let's say, 2.4. Then you will see that it's going to 2.4 multiplied by 5.8 will give you the blood glucose level. It is not this model that you cannot recommend that based on this my model, you cannot use it to develop app. All this AI and some other things like that. The background of it is all this statistical and mathematical model. So you cannot go further. Okay, I want to develop an app that is, if you supply your age to that app, and then you know your BMI, and you know your hemoglobin A1C, this app is going to predict your blood glucose level. That is, madam or brother, your blood glucose level is going to be this. This model too can also apply you can apply it in finance. Let's say, for instance, now instead of age, is the amount that you spend on ad. Instead of BMI, is the time that your customer, how often your customer comes. And then instead of hemoglobin A1C, it will be the amount of goods that your customer buy. that you cannot predict your sales. Let's say, for instance, now you want to use this in agric. The age there can be the type of seed that you are using, the durability of the seed, or the lifespan of the seed. And then BMI can be the soil texture, whether it is acidic or alkaline. And then the hemoglobin A1C will be the amount of water that you supply. Then you can predict the yield of crop. So in any field, in law, you may want to use this model to predict. And then all this variable is going to be what? You're going to put it in what? In your field context. Then you have your model. So this is how we normally carry out a simple analysis using MS Excel. The floor is now open for question. Any question for me, please? Thank you. So you have the floor now for questions, and I'm ready to answer. Okay. Madam Comfort, please go ahead. Go ahead, please. Go ahead.
Yes, sir. Thank you, sir. Well done. Sir, this,
I'm going to call you one after the other, please. Let's if you want to talk, just raise up your hand, and I'm going to call you, please. If you want to talk or you have questions, please kindly signify.
Hello, sir. Well done for your effort. Can you place back your table, sir? I want to show you something that I didn't understand there.
Yes, ma'am. Go ahead.
Can you place back your table, sir? Where did interpretation? He's not hearing me. Hello? I can't hear you. Hello, sir. Network. Hello, sir. Network. I can't hear. Is somebody hearing me?
Yes, we can hear you.
Yes, we can hear you.
Okay, sir. Sorry, this the where your
yes, can you see my
90 point? Yes, I can see now. I can see it now, sir. Yes, sir.
Yes, sir.
That 90.94.
Oh, maybe
Sir,
you should
you
type
didn't.
it on the chat box, and so I can read it from it. You can type it there because I can't hear you. So
Okay,
you can
sir.
type it on the chat box. So let me give room for others to ask their question. Okay, you can type it on the chat box, please. Mr. Ayobami, please go ahead.
Thank you. Can you hear me, sir? Can you hear me, sir?
Yes, we can hear you.
He's trying to
Please,
reconnect.
can we all mute our mic? Can we all mute our mic? So if Aziz, please mute your mic.
Can you all hear me, please?
We can hear you now.
Oh, sorry, please. I have to change my location. So you can hear me now, please.
Yes, sir.
Yes, sir.
Clear.
Okay, so let me share my screen again so that I can welcome questions. Let me share my screen again. Let me share my screen again. Okay. The floor is open now. Madam Comfort, you are asking question. Please, can you ask again, please? Can you ask again? Okay, if not, let's
Hello, sir.
Mr.
My
Yobami.
question is
Okay.
that if the blood glucose level of unborn child is 90.94, so you said it is not possible, which is not true. Is that the interpretation of it, or there's another thing you will now say about it?
Yes, that is why you don't interpret it in isolation. You don't interpret the intercept like that. So you interpret it along with other variable. So, but if you give it to the quack analyst, they will just interpret the what's it called? Intercepts like that. So, but in the real sense, we don't interpret it like that because it is not practicable.
Yes, so you have to
check
interpret with the remaining variables. Yeah.
With the remaining variable, yes, with the remaining variable. With the remaining variable. Yes, yes. Okay. Mr. Yobami, go ahead with your question.
Thank you, sir. My question is still concerning the interpretation of the regression analysis, sir. So from my experience, when I did my undergraduate study, with the sample that was given to me as a project sample, I was told that when we are to interpret the regression results, based on each variables, we are to shows how significant they are to our dependent variables are. And that is what I wanted to ask. Is it supposed to be like that, or there are ways that different fields does their own?
Okay, that's a very good question. Irrespective of your field, the first thing that you have to do in regression is that you have to interpret the coefficient of each of the variable, your independent variable, how they contribute to the outcome. That is the first thing, which we've demonstrated tonight, how age is contributing to the blood glucose level and some other variable like that. That is the first thing. Then the second thing that you are going to be using is that you are going to be checking the significance of the model, how significant this your model is. And then you are going to be checking the what we call the R square, that is going to be telling you the contribution of all those variables. The contribution of all those variables. Now, another thing that you can still do, that one is still further research, is that you are going to take you can test the hypothesis for each of the beta, each of the coefficient for age, the coefficient for the BMI, the coefficient for hemoglobin A1C. You can test it individual for them. So instead of testing them together, so that means that you are removing two variables. Let's say, for instance, that you are leaving only the age. You are not adding the others. So you will check whether the age is significant and some other things like that. Then you remove the age. You put the BMI. You check whether it is significant or not. You remove the BMI. You put the hemoglobin A1C, whether it is significant or not. Then you will now do what we call the joint contribution. So which is the multiple linear regression. So you can do that. So I think that is the standard way of interpreting it, whether you are from education, any field. That is the standard way of interpreting it. Then you write out your predictive model equation, which we've done tonight.
Thank you, sir.
Okay. Mr. Babafemi, please go ahead with your question, please.
Thank you very much. Please confirm that you can hear me.
Yes, I can hear you perfectly, sir.
Oh, okay. So thank you very much for the very detailed explanation. I actually got your explanation, but I missed one or two steps in when you were doing the analysis.
Okay.
I don't know if it's possible, yes, but the explanation was very clear. I just missed a few steps. Right.
Okay. Let me take other people questions. Then I'm going to round it up with that.
Okay.
So
thank you.
Okay. Shola Adedoku, please go ahead.
Thank you so much for the lesson, sir. I think I have the same question with Eve. I missed out when you're about to click on the analysis tools.
Okay. Making two like that, no problem. Please, Oladiran, go ahead with your question.
Please, I'd like you to explain that ANOVA table again. I didn't get the explanation very well. Please.
Okay.
Thank you.
Okay, I will do that. Madam Oluwabumi, go ahead with your question.
Yes, sir. Good evening, sir. When
Evening, madam.
you were completing the test statistics for the relationship between gender and BMI, you said you assumed unequal variance, same as when you did for the other variables. So, and in the data analysis part, I saw that there is an option for equal variance. I just want to know why you guys
Yes,
put
it depends on you. It depends on you. We have homogeneity of variance. Homo means equal. From the word homo. Homo means equal, and then we have heterogeneity of variance, which is me unequal. So if you assume that the variance are equal, so that means that if you are using unequal variance, you have to state it in your paper or your research that you are using unequal variance, because by default, we are using equal variance rather, because by default we assume that it is unequal variance, heterogeneity of variance. But if you are using equal variance, you have to state it in your write-up that the variance that you are considering in this research or in this dissertation or thesis, you are using equal variance. So that's just there's no difference between if you run it, you have the result, but just let them know that you are considering the equal variance. Are we clear that? Are we clear with that, please? Okay, so let me quickly run through the regression again, and then we interpret again. Okay. Sheet 1 is our data. Let's look at it again so that we use that to call it a night. Now, once you have this, what we want to predict, which is our dependent variable, is the blood glucose level. Blood glucose level is our Y, which is what? Which is dependent variable. Age is one of our predictors, which is independent variable. The BMI is also one of our predictors, which is independent variable. And then the hemoglobin A1C is also one of our predictors, which is independent variable. Now, once you click on data analysis here, immediately you click on data analysis, you look for look for regression. This is regression. Once you click on regression, it's going to bring out boxes for you. We have two boxes here. The first one is for your dependent variable, which we categorize as Y, which is what? Which is called Y. Your dependent variable, which is Y. Why the second one is for your independent variable, which is X, which is also called the predictors, or we call it explanatory variable. So now, to put here in Y, once you click the first cell here, then the next thing is you can just press Ctrl Shift down to copy everything, to take every Y, all the Y's in. So once you do that, then you come to your X, which you want to use for the explanatory variable. So once you click on the first one, which is the age, then you can drag it to the BMI, also to the hemoglobin A1C. Once you do that, you now press what? Ctrl Shift down. Immediately you press the Ctrl Shift down, it's going to capture everything. It's going to capture everything. So once you do that, then you press OK. Immediately you press OK, it's loading. So it's going to bring out the results for us. It's going to bring out the results for us. Now, the result here, let me now go back to the first result that we have, which I have put some things there. We start from the regression statistics, and the only thing that we need here in regression statistics is the adjusted R square. Adjusted R square is telling us the amount of contribution that those predictors are contributing to the outcome. And then from the adjusted R square that we're having here, when you multiply this by 100, we're going to have 3.9%, which means that those predictors, the 3 predictors, contributed only what 3.9% out of 100%. So that is just this. Now, to now check the significance or the model adequacy, we normally use the F test, which comes with the analysis of variance. And then the only thing that we normally use here is the significance of S, which we normally call this one p-value. So normally we normally call this p-value. This is p-value. Let me put it as p-value. 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 So it is not this one that you are going to compare with the 0.05. So since this one is less than 0.05, it means that your model is significant. Your model is significant, statistically significant. Now, after that, then we come to the table for, what's it called? The table for coefficients. The table for coefficients. Now, the table for coefficients, we have x variable 1, which is our what? Which this one is our age. Let me put age there. So we have age, and this one is our BMI. This one is our BMI, and this one is our what? Is our hemoglobin A1C. We have HbA1c. So now, if you now look at this, we want to write out our model from here. We want to write out our model from here. So we have blood glucose level, which is equals to our intercept is this 0.94 plus the coefficient for age is 0.139, but we are approximating to 2 decimal. So we have 0.14, then we have age plus, then for the BMI, we have 0.32 BMI plus the hemoglobin A1C, we have 5.88 to the 2 decimal. Then we have the hemoglobin A1C, which I've interpreted for us. That is, a unit increase in age will lead to 0.45 increase in blood glucose level, provided that all other variables are constant. And then for the BMI, a unit increase in this is going to give us 0.34 increase in the blood glucose level, provided that all other variables are constant. And then a unit increase in the hemoglobin A1C level is going to give us 5.88 increase in the blood glucose level, provided that all other variables are constant. Okay, now another thing now that we want to check here is the p-value. You are going to check for significance of each variable, the beta. Oh, thank God we even have it here. That was what I was explaining to someone, to Ayobami, that we have to take it one by one. Now, if you look at this, the intercept is less than 0.05. That one is not even our business. Now, if you look at this, this for age is 6.0 times 10 raised to power minus 21, which is very, very low compared to the p-value, compared to the 0.05. So that means that age is highly significant. The age here is statistically significant. The same thing goes for the BMI. BMI too is statistically significant because it is less than 0.05. And then for the hemoglobin A1C, the p-value is 0, which is less than 0.05. It means that the hemoglobin A1C is also significant in contributing to the output of blood glucose level, although the contribution of all of them is still 3.9%, which is very, very low. Lastly, before we call it a night, another thing that I want us to check is the confidence interval. The confidence interval. The reason why we normally ask for the confidence interval, and then even in some high-rated journal, they will ask you, if you supply p-value, they will say, give us the confidence interval. Because there are some tests that are statistically significant, but not clinically significant. Statistically significant, but not clinically significant. And also there are some tests that are statistically significant, but in your field, it may not be significant. Now, we check the p-value. How do we interpret p-value? In p-value, we have the lower band, and then we have the upper band. Anytime you are checking this p-value, and they have the same sign, confidence interval, and they have the same sign. What did I mean by the same sign? If you look at the confidence interval for age, the lower band is positive 0.12, let's say 13, and then the upper band is positive 0.15. So they have the same sign, which is called a positive sign. Immediately they have the same sign, which is called the positive sign. It means that that variable age is statistically significant, which is the same thing that the p-value is saying. And also, if you look at the same thing for the BMI, they have the same sign. Immediately you have a confidence interval with the same sign, it means that it is significant. Also for the hemoglobin A1C, they also have the same sign. So it means that it is significant. So that, you know, sometimes when I check some journal, I will see that the p-value is saying it is significant, but the confidence interval is telling them that it is not significant. That means that you have to go back and check your analysis, because both of them, they are not antagonists. That is, if p-value is telling you that it is significant, automatically confidence interval will buttress that point that it is what? It is significant. So, any other question, then we call it a night, please. Any question for me again? Any question? Any contribution? Any addition? Okay.
Hello, sir.
Okay. Okay.
Sorry,
So
this confidence interval that you said they are the same. Is it because it's not minus?
yes, because it's not minus. Thank you. Immediately one is minus and the other one is positive. It is not significant. But if both of them are minus, minus, negative, negative, they are still significant because they have the same sign.
Okay, sir. Thank you.
Did you get that, ma?
Yes, sir. Thank you so much, sir.
Okay. Thank you. Thank you. Thank you. So I'm going to send some information to the group, and then please let us read it and also look at it, and then make sure that you act accordingly. And also, by now, after this class, I'm going to call my IT to open the backend so that you can download it. Although from our previous one that we have been doing, we don't give download. We just ask you to go and go over it, since it's going to be there for a year. So after a year, you will not have access to it again. But I'm going to give room for downloading for this cohort. So in the absence of no question, thank you so much. In the absence of no question, next week we are going to be launching to SPSS. We are going to be launching to SPSS. At least with the knowledge that you have on this Excel, you can pick up your data, use Excel to do the analysis, and then bring out your results. So thank you so much for your time. For our brother that joined from Ghana, we say a very big thank you to you. For those in Kenya, the Australia, the United States, and then our own here in Nigeria, you are the best. Thank you so much. See you next week. Do have a wonderful night. Good night.
Thank you, sir.